happen. Always go by assignments, and of course I'll always go by assignments, but there's a strong possibility you'll have a quiz on law of cosines in the next class. If not, in the one after that, but the test is coming soon, so I want to make sure you know law of cosines. But I'll put if there's a memo quiz, I'll put that in assignments. If there's a quiz on law of cosines, I will put that in assignments. All right, the law of cosine, oh, by the way, look back at a triangle. It could be oblique. I'm sorry, oblique just means it's not a right triangle. It could be obtuse or acute. And if you have obviously it could be a right triangle. Girls, please don't forget, if you know you have a right triangle, just go back to the old easy stuff that you learned in the 9th grade. Okay, like SOHCAHTOA, a squared plus b squared equals c squared. I have shown you where these are derived. And this hinge theorem that your geometry teacher taught you is like super important here. The side opposite A is A, B, C. I don't need to reteach you geometry. Thank goodness. Okay, so what's happening with law of sines? And Danielle, we were talking about this morning kind of. With law of sines, you have two sides that cannot change. A and B. Okay? And then you would have to either have angle A or angle B to use the law of sines. So let's say I have angle A. What angle would you be finding first? B. Angle B. Do you see that you don't know how these are hinged together? You don't know C yet. You also have no idea how long this side is. Okay? These can't change right here. But do y'all see I could make them the same size, and I could have them like this. For all that matter, I could have them like this. There's just so much you don't know. Okay? Do y'all all see where the ambiguous case could come from? Let's talk about finding angle B. Since you don't know how this is hinged together, you certainly don't know how this is hinged together. I've shown you, instead of drawing on this screen, some really good animations of the two triangles that we created. And if you think back to that animation of the law of sines, those sides were not changing. The angle that you were given were not changing. The three givens were not changing. I saw a few eyes, brows raised. So maybe you've forgotten that, or it didn't mean anything to you the first time I showed it to you. So it's under topics. You can view it at your leisure. Law of sines and cosines. Oh, by the way, here's a law of cosines calculator down here. So I don't think you have the answers to your worksheet, but and these calculators aren't super user friendly. You could find another one that's not on my website by typing in Google law of cosines calculator. And you could put in your sides and it'll tell you the answers to however many decimal places you need. So you could check your whole worksheet if I never provide the answers to you. But let's go back to this. I think it was this one. All right, so that's a no triangle situation. But notice A is not changing. A is 3. B is 9. Angle A is 30 degrees. I cannot change those. Those are my givens. That's what I have to work with, okay? Now, if there's a certain place, I think on this one it's actually at 4 or 4.5, that it only makes one triangle. It doesn't have to be a right triangle. At that point, it drops straight down, and that's all that happens. If I move this leg 4.5, it'll be too short either way, and it hits right there. Okay? So that's a one triangle situation. Do y'all see now I've changed A, but once I go, I'm still going to go to A is 5. So here's our givens. A is 5, okay? A is not changing. B is not changing. Angle A is not changing. I cannot change those. That's the money I have to spend at a store or whatever it is. You know, you're a certain height, weight, and got some money in your wallet or on your debit card. Those three things aren't changing. If you want to wear, there's times you may have gone in and there's like a extra large sweatshirt that you really loved, but it's not going to look very good on you because that doesn't fit the criteria that you walked in the door with, okay? Or my husband is an extra large, so, or at least an XL, depends on the pattern or the sweatshirt. But anyway, he could walk in as a large man. he's almost 6 feet tall, and he might have certain money in his wallet and go into Modell's to buy a sweatshirt. And he was like, oh, I really love this. Well, obviously like red. He wears a lot of black and gray. Anyway, he could go, I really like this red sweatshirt. And sir, all we have is a medium. That's like a no triangle, right? What also could happen is there could be an XL and a double XL, and maybe he's got a choice between how loose or tight he wants it to fit. Do y'all see what I mean? You walk in with Gibbons, he can't change that. He's not all of a sudden going to be a skinny, short guy while he's standing in the Modell's looking for a sweatshirt. These Gibbons can't change. Okay? How is that real world? We're all going to have Gibbons in our life. When you go looking for a house to buy or an apartment to rent, you're going to go, I've got 2 kids. I at least want a 1-bedroom, if not a 2-bedroom. I have a salary, so therefore I have a budget. There's going to be some givens, and then there's going to be some options. Okay? Rebecca?
Last year in geometry we did like the similar triangles and then the congruent triangles and like the SAS and like all
Yeah.
The ones that were the congruent ones, those are the ones that like there's only one.
Yes.
And the ones that are similar, there's more than one.
Thank you so much for bringing that up. Because you said that the other day and I never really addressed it. The one that I'll call SSA instead of the ASS, okay? And so that's the one that you couldn't ever use as a proof. And I think that's kind of where you're headed in a way, or at least it made me think of saying that. Remember, you couldn't prove anything with some teachers call it the donkey theorem, okay? Because if you have 2 sides and an angle that's not hinged, if it's that side angle, you can't prove anything. You can't prove that I have this certain triangle, where you could with some other things we're going to talk about, but I need to hurry on through. But the point is if I have an A and B and one of the angles that is not in between those, it's ambiguous. There could be 1 triangle, there could be no triangles, there could be 2 triangles. And your given statements will dictate what happens to you. Okay? So I don't know if maybe I went off road on that one. Okay? But all that side angle side and side means a whole lot. Okay? So I've been wanting to say that since Isabel brought it up the other day. Now look what happens if I have 2 sides and the angle between them, which, by the way, do y'all notice would be ABC or BCA? Do you see you're always going to have 3 different letters? And that's your hinge theorem. That would be a side angle side, which you definitely use in your geometry proofs, right? Do y'all see that set in stone? If I go, here's a side, and there's the angle between them, you can't change that. All right? So if you have side angle side, you're only going to get 1 triangle. And when are you going to use the law of cosines? When you have an A, a B, and a C, 3 different letters. Now let's talk about side, where you have 3 sides. If I gave you these 3 sticks, okay, and if I gave them to Grace, and then I gave them to Michaela, and I gave them to Zaina, and I said, okay, here's these 3 different size plastic straws or whatever. Build me a triangle, and I let them have a second. And I looked at Zaina's and Michaela's and Grace. They would all have the same triangle. There's only one thing you could do if you know all 3 sides. Now, Grace's might be turned differently than Zaina's, but then I would turn Zaina's and they'd look exactly alike. They'd be the same triangle, like this. These are all 3 very magnetic. These are all 3 the same triangle, aren't they? Like, now are they the same triangle? Yeah. All right. So that happens with all 3 letters. If you have all 3 letters, there's only 1 answer or possibly no answer if one of them is not long enough. Okay? All right, so now moving on. So let's go to law of cosines. What was number 1?
Of like the areas or the normal?
Of the normal.
C equals 104 degrees. A is 10 and C is 12.
C or B.
C.
C is 12. All right, so now you had decisions to make. What law would you have to start with? Law of sines. And most of y'all probably stuck with the law of sines here. All right, in the 2 triangles that'll be on quizzes and tests, Wouldn't I just cross this one out for sure? Because I already have one obtuse angle, there can't be another obtuse angle. Here's how the law of sines works. Why the law of sines can throw you into the ambiguous case, and the law of cosines cannot. Okay? Law of sines, girls, is ratios. Isn't it all division and multiplication?
Mhm.
So it's going to be positive no matter what. Would y'all agree with that?
Yes.
Okay? Sine is positive in both of these quadrants, up to 180 degrees. These are both viable. But inverse sine will only check this one. So that's our dilemma. That's why law of sines can run us into the ambiguous case. Law of cosines, cosine goes like this. Sorry, that was a plus. This is cosine. Okay? Cosine's got some adding and subtracting in it, doesn't it? Girls, if you start adding and subtracting numbers, you could get a negative.
Yeah.
Couldn't you?
Mm.
What is inverse cosine? See how all this merges together. What does inverse cosine check? What quadrants? First and second, 1 and 2, which takes us as far as we need to go for a triangle. If I'm working on triangle problems, that's all I care about. So I love the law of cosines for a few reasons. One reason, I'm not going to run into ambiguous case, which I don't like, and neither do you, just because it's more work and more decimals to keep up with, okay? But it's not going. You should not come into ambiguous case for the reasons that you'll have 3 different letters. So whatever somebody gave you is set in stone. Like this can't change. Okay. Also, if it's positive, it'll spit out an acute angle. Do y'all see it has the power to find an obtuse angle? If you get a negative when all you're adding and subtracting, it'll bypass the first quadrant looking for your negative ratio. So it will find an obtuse for you. Do y'all see, since this is positive and this is negative, there's not going to be any ambiguity. Since this is positive and this is positive, there's some ambiguity. Okay?
Because the law of sines can only find like the acute angle.
Right. Okay? But law of cosines can find obtuse, and I don't need to go past 180. Now, if I'm working on some other application that's not triangles, then I have a dilemma with cosine, but that's not going to happen here. All right, and so y'all probably found angle A, then that led to angle B and little b. Somebody want to volunteer to call out the answers? All right, Isabella?
A is 53.957 degrees.
957?
Yes. B is 22.043 degrees. And little b is 4.642.
Okay, and I saw some people nodding, and just graded your wonderful quizzes. Your awesome, sound like say awful. Your awesome quizzes, and y'all were getting the same 3 decimal places. It was so wonderful to grade, and you X'd out your boxes and all of that stuff. So I graded them really fast. It was wonderful. Okay, so that was number 1. All right. Everybody okay? That's law of sines. But I wanted to throw some of both on the worksheet. All right, number 2. Somebody read me number 2. Grace Hooper, you want to do that?
Yeah. Angle A is 16 degrees. Little b is 12. And little c 17. Little b. They sound
Little
like
rapper
rappers.
names.
Yeah.
Like little c.
Little b. All right, little
Emily
b.
calls me Big C.
All right, ABC, I'm going to use the law of cosines, okay? So I'm going to say a squared equals b squared plus c squared minus 2bc cosine 60. You want to make sure you're in degrees. What was 144 plus 169? Oh, wow. Did I add that badly? Is it?
This is very 17 squared.
Oh, thanks. It's 289. Thank you. I was doing 13 squared. 17 squared is 289. So you got 4, what? Huh? 433. All right. And 2 times 12 times 17? You may not even know what it is. 2 times 12 times 17. Chloe, do you have that?
Yeah, it's, 2 times 12 times 17.
That's all I want right now.
408.
Thank you. Cosine 60. Okay? Remember I said you'd be tempted sometimes to subtract those 2. They're almost always close together, but that's not a 408. It's a 408 cosine 60. By the way, I'm fine if you just type that straight into your calculator and square root it. All right? And so what did you get for A? Anybody? 0.133. Okay, then some of you probably switched over to law of sines. Some people stayed with law of cosines. You can stay with law of cosines, okay? But if you switch over to law of sines, watch what happens. Right now, there's no reason that you would think I would want to do this, but let's say I want to find angle C next, okay? So I'm going to say A over sine A equals C over sine C. And now I'm going to cross multiply. I'm going to need some help here. So I have 17 sine 60 equals 15.133 sine C. And this may work out. If it does, I'll just keep moving. I don't know if it is or not. I'm going to divide this by 15.133. Some of you that are helping me out here, hopefully you'll say 17 times the sine of 60 divided by and pull that big number down. And then push inverse sine. Tell me what you get for C.
76.623.
Is that what you got for C in your work?
Yeah. I heard 77.
Oh, wait. All right, let's
76.62.
Yeah, me
so
too.
it's-
I got 0.65.
76.62,
I got 0.627.
I got 0.8. I got 8.
but it may have rounded to an 8. It sounded like to me from listening to people that it was mostly 0.627 something that may have rounded some people up to 8. If you got 625, I'd count off, okay? Because you should use this big number that's in your calculator, not your rounded number. That may be what's happening. Okay, so that worked out fine, I think. What was angle B?
42.6.
Okay, so what I thought might happen didn't happen there. So we're going to move on, okay? I'd have a little box for you to write all three of your answers in.
I didn't get that.
I found B first,
I got
so my answers were different.
43.372.
Okay, maybe this is what I wanted
Because
to
I
happen.
did 42. I did B first.
Oh.
I found B first,
And then I
got
did C second.
43.375.
Okay, time out. Everybody stop. 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 Maybe it did happen. Okay, Katie, I think, did you punch this in to find angle C? What I was
I
doing.
swapped cosines.
Okay. All right, Chloe, did you type this in for me? I don't know who typed that in. All right, and what I need right now is somebody to put in 17. I wasn't asking for your answers off your worksheet. I need somebody to go 17 sine 60 divided by, let's just say 15.133 right now because we don't have a longer number.
0.9. What do you want me to?
And then inverse sine.
76.623.
Okay, and it's probably that because of this rounding problem. Okay, so I think everything's fine. So let's go back to the answers. All right, so B. Katie, what'd you get for B?
I got 43.373.
Did anybody else get 43.373 and 76.627 or 628?
Oh yeah.
Okay. All right. Girls, you may have heard Katie say she stuck with law of cosines. Law of cosines is super safe. Law of cosines is super safe. Okay? Because it'll check first and second quadrant. All right. What was number 3?
A equals 36 degrees and that's 11.
Okay. I want one where I gave you all 3 sides.
Oh,
4.
4?
Yeah.
A equals 4, B equals 6.
And B equals 3?
C equals.
I'm sorry. B equals 6, C equals 3.
Yeah.
All right, so law of cosines, if I find A first, watch what happens, girls. And this is where you super need to listen. Big time. Okay? If I say A squared equals B squared plus C squared minus 2BC cosine A. I'll have 16 equals 45 minus 36 cosine A, I believe. You could do as much on your calculator as you want to. What's 16 minus 45? 29 equals negative 36 cosine A. Now, watch this. There's sometimes you subtract these two numbers, and this one's positive divided by a negative. So you could get a negative. Right now, we're going to get a positive. So y'all divided and pushed inverse cosine and found A. What'd you get for A? 336. Like blah, 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 blah. So a lot of, you want all the decimal places. I may lean on Chloe for this one, okay?
Wait, after it's 0.
Yeah.
And after that?
0, 5, 7.
Okay.
5.
So anyway, use answer.
Have to only round to the third place.
Yeah, but I'm going to keep going, so I want that. I'm going to keep depending on you, so I want you, you don't want to use that rounded off number in your other computations. That's how some people were getting off on their third decimal place here, which is how they count off. You got to right answer,
Alright.
okay? All right, now some people probably switched over to law of sines. Some people probably stayed with law of cosines. A whole lot of you probably switched over to law of sines and found angle B next. Did that happen to some of y'all?
Yeah.
All right. So I'm going to say A over sine of A equals B over the sine of B. I'm going to cross multiply. 6 sine of 36.336 equals 4 sine B. Divide by 4. So what you should do is go 6 sine of 30, you should go 6 sine and pull that number next to it with your calculator. The full number. Yes, you don't want to round as you're going in your computations, whether you're an accountant or an engineer or whatever. If you take a rounded number, you could easily fall further off the mark of what we're requiring. Okay? And it hasn't happened to you yet, it's just coincidence.
You can just do second answer.
Yeah, you can do second answer, or all your calculators now have to, we used to have to store it, but, or second answer, but now you can even scroll up and enter and it'll bring it down.
Really?
Yeah.
Yeah, that's what I did.
Yeah,
Elena, which is nice, because you might need to go back and get another number, yeah. Because second answer is only going to do the last thing you found, and you might not want that.
Right. Wow.
Yeah, we needed to get all that.
That's fine.
Okay, who can tell me angle B?
62.720.
And angle C, what'd you get? 80 point,
90. Oh, well, wait.
oh, sorry.
Now it would be messed up. Oh, yeah, because I did it.
Okay,
Well, can you just subtract those?
yeah, from 180, that's what I'm,
Subtract those or do you
8.94.
subtract the full thing? The full thing.
Oh, I've just been using the.
wait, you would say 180 minus these two.
Yeah, but the full number or that?
No,
Oh,
the
at that
rounded.
point, I would still use the full number. It's so important that you don't round as you're going, because you know one answer to find another answer to find another answer to find another answer. You may be one that had a 625 up there where we had a 627 and 628, and that's why that's happening.
But like when you're finding like the, I don't know. I've just been doing it wrong, but it's been fun.
But it easily could not be. But do you understand that,
Yeah,
like,
no, I
as your
understand.
teacher, you're getting so close to college and a profession and research and whatever. It's
I
important
just-
to be
I
precise.
just thought once you had it like here, like next to sign, you just use that.
Well, I'm saying,
I know. I'm just
Okay.
saying.
Elena.
80.944.
Okay, I am so sad that Grace Marie just left. Hopefully, we'll remind her this is real important to watch what just happened. Okay, Chloe, watch. First of all, I'm going to look at some things. Like, shouldn't the biggest side be opposite the biggest angle? doesn't look okay to me. Does that look okay to you?
I did, I
Hang on, Katie, just a second.
So then
Okay. Time out. Okay. Oh, no, I didn't want to do that.
And the rest of it? And the rest of it?
Did you get that?
Did you go, what was that?
Hey, girls. Right now, it doesn't matter to me what you got. Because you should be sitting here going, something's wrong. Now, if you're listening to what people are like comparing that got the right answers, they got different answers than I just did. But a whole lot of people would find a side and then go straight and find the angle, okay? The people that got it right, my guess is they at least stuck with law of cosines for one more answer, okay? And so when we were writing angle B up there, they were probably like, that's not what I got. Here's the issue. Which one's the biggest angle? B. And it's just got to be bigger than 36. Are y'all with me? But couldn't it be bigger and be acute? Or bigger and be obtuse? Now I told you with law of cosines, there's no ambiguity. And all of a sudden it sounded like, oh my gosh, I could miss the problem. There's super smart people in this room got two different answers for B and C. Okay? That's why I want you to listen so hard. When I'm finding the biggest angle on law of cosines, I would never switch over log signs for that, ever. The biggest angle might be obtuse. Is law of cosines capable of giving me that obtuse angle? It's not capable of doing that. What is law of cosines capable of doing? Checking the first quadrant. Only acute. Thanks, Chloe, okay? If it's obtuse, it will never tell you that. It cannot check it. So I'm going to stick with law of cosines like I think Chloe and Katie and maybe some others did. All right, law of cosines. Watch what happens. If now I go B squared equals A squared minus C squared. Sorry, that's plus. A squared plus C squared minus 2AC cosine B. I have 36 equals 25 minus 24 cosine B. I have not taught a year yet in my career that somebody didn't call that one cosine B. I hope that doesn't happen this year, and I always make a big deal about it that you can't do that. Do you see how tempting that is? Okay, so I'm going to subtract 25. Is that 11? So I get 11 equals negative 24 cosine B. Divide by negative 24, and look what I have on the left-hand side. What kind of a number do I have? A negative. I don't know what 11 by 24 is. What's 11 divided by 24?
Negative
0.458. Thank you. All right, now push inverse, timeout, don't, if you're following along. You're going to push inverse cosine, and it's going to go choo-choo-choo-choo-choo. It's not going to find anything in the first quadrant, so where's it going to go? Into the second, where cosine's negative. It can find obtuse angles. What is B? I believe 117.
279. Or 2. Yeah, me too.
Okay, so it's probably around the issue.
Yeah.
Hey girls, I bet this 62.720 is like the reference angle if you subtract that from 180. You don't want to put yourself in that position, okay? And here's something scarier. There's times I've done this for a class, and you would have been never known something was wrong. I've seen it go small, large. You know, I've seen it like fit what I thought should happen. The biggest angles opposite the biggest side, but still the angle was wrong. Okay?
So if we can.
So what happens is this. I'm going to give you two things. So I'll give you a so, all right? At least through the second angle, Katie and Chloe are doing it. Stick with law of cosine. Some of you others, I'm sorry, I may not be giving credit where credit's due. But just stick with law of cosines. It's super safe. It'll parse through what's going on. If you say inverse cosine of a positive, it'll go, here's your acute. If you say inverse cosine of a negative, it'll go, here's your obtuse. Okay, girls? But watch this. I'm going to get it right a different way. Watch. So Grace, we just missed that problem while you were out, but now we got it right. So that was the big discussion I was building up to. Okay, I missed it on purpose. So you may want to kind of go to this part in the video. All right, girls, now use your brain that I've talked through all of that with you. Or if you don't want to think through this, just keep using the law of cosines. Okay, that's safe. All right, but if I like the law of sines and I want to switch over to it, I'm going to do it with great care. Tell me what kind of an angle law of sines can find. Acute. So this one's definitely acute, isn't it? I'm going to switch over to law of sines with that one.
Yeah,
That's
what
what
I-
Okay.
that's
Good.
what I did.
That's not.
Yeah, and it'll work. So you thought about all of that. Wow. Okay, so I can say A over sine A equals C over sine C. C's acute. It will find the correct angle C, and then you subtract to find angle B.
That's what I did.
So when you're using law of cosines,
I found the second triangle, and then the first one didn't make sense, and then I stuck with the
but
second.
there's not two triangles.
No, I know.
Okay.
The first one didn't.
So you could rule it out.
Yeah.
This is where it's scary. You could do this, and the first one would make sense, but it's wrong.
Right. Okay.
You see what I mean?
Yeah.
So it kind of had this weird twist in it that the angles didn't match the biggest size.
Mhm.
But I've done it most times where I had small, medium, large, and my angles went small, medium, large. They were just wrong.
Okay.
Okay?
Yeah.
There's only one way to put three sides together. If you stick with law of cosines, it'll give you the obtuse angle. This one had an obtuse angle, 117 something. So if you're one that likes to do the law of cosines to get the missing angle or the missing side, and you want to switch the law of sines, I'm fine with that, but it only go for the what angle?
Cute.
Acute. If you switch the law of sines, find the acute angle next. Okay? Here's the way I would have done this problem after all that talk. Okay? After all my experience, and wow, y'all blowing me away with how you've already thought through all of this. This is amazing. You're an amazing class. Somebody else may have thought of this and maybe still in the thunder. Law of cosines is so awesome. If any of these are obtuse, which one will it be? I wouldn't have found A first anyway. I would have used law of cosines and found angle B, and then I could work the problem however I want. Did you do that, Grace? Good. Awesome. Wow, that's just a lot of intuition, fluency in this mathematics. So anyway, anybody else do that besides Grace? Good. Okay.
Yeah, I found B with log cosine.
Cosine.
Yeah.
Do y'all see how you can look at it now and target that? Okay? All right, now we're going to talk about, for a few minutes, something new that's super fascinating. Now, actually, I see it on the back of the board where Lily and Danielle were working today. I think that may be their work with the 2i plus 3. Oh, no, that's probably from another class. That was that yours?
No.
Right? Okay.
Below it is.
Below it is just physics. Okay, in physics, have you done vectors?
Yes.
Okay, we're going to touch on that some, all right? I'm not going to full-fledged go completely vectors, but you've got to do trigonometry to do vectors, and we're finishing up our trig. But what we're going to do is we're going to go into the imaginary numbers. A long, long time ago, they named them the imaginary numbers. I don't know who did it. I so wish they hadn't. Okay? Because they're not imaginary. Like, if I go to the...
Is that like I?
Yeah, it's I. But all it does is throw us into the set of complex numbers in our world. Let's see what I Googled that was so good. I Googled the reality of imaginary numbers. Okay? They're real. They're not imaginary. Somebody, I guess, thought there wasn't that other plane out there. It's almost like saying that there's only two dimensions because we have X and Y. All right? I'm not going to go to all of these, but I'm going to go down to this one. What use are imaginary numbers in real life? In addition to art and music, I thought it listed, sorry, that's not the one I wanted. Oh, I don't want that either. I think it was this one. Which one did I click on? Now I can't remember. But anyway, it gave a list of professions that use imaginary numbers. All right, so let's talk for a minute. Oh, there's another thing I wanted to look at. This. Oh, this is what I was thinking of. Applications. There's only a few girls in here that talked while I'm talking. And I guess on some, it just is actually rude. Just because if everybody did it, then it would be really, really loud in here. So most people don't do it, thank goodness. So anyway, applications of numbers. What did I Google? I'm sorry, not of numbers, of imaginary numbers. If I go to images, you'll see a lot of applications of imaginary numbers. Right here is a lot of art that you may have seen if you've seen fractals in the Mandelbrot set. To make those beautiful images, you have to use what is called imaginary numbers. And, you know, there are videos and stuff I could show you, but let me move on so that we're talking about it. Imaginary numbers are used in electrical engineering, and art, and music. I've had students that actually created probably have at my filing cabinet, a CD, long time ago when there were CDs, that I could put in my computer and listen to. They made music using imaginary numbers, okay, and quadratics. But anyway, what happened is you run into square roots of negatives, and we start to say undefined, but in our world, there is the complex number system. We operate almost exclusively in high school in the real number system. But there's actually in our world the complex numbers, divided into real and imaginary.
Miss Arkin made us write this down the first day in algebra.
Yeah, we're pretty adamant about it.
I
Yeah,
remember
yeah, that's awesome. I'm glad you remember that.
Is that the same day I asked you?
We spend almost all of our time here, but really many numbers are what we call complex. And teachers even tend to say just imaginary and real, but we really have to look at numbers that are complex. They have a real component and an imaginary component. We even graph them, like 3 plus 4i. I call this the real, not me, they call this the real axis and the imaginary axis. Vectors and polar graphing and stuff you'll see start to come into play here. So you go out 3 and up 4, and you graph that imaginary number. I went out 3 on the real axis, up 4 on the imaginary axis. And what we've done right now, if you've studied physics at all, do y'all see a vector?
Yeah.
Okay, it has magnitude and direction. In our math book, they call the magnitude the absolute value of the complex number. You probably also heard that somewhere about magnitude of a vector. Raise your hand if you've not had physics. Okay, that would have been me. Okay, so don't be shy. So you've all had physics? And you've seen vectors, magnitude, and direction. Okay, to find the magnitude, you say the square root of the x component and y component added together. So you're finding the hypotenuse. That's how I guess you find the magnitude. This also called the absolute value. Sometimes it's even like this of a vector. So I'm going to take the x component 3 and just the 4, and I get square root of 25. Obviously, this was a 3, 4, 5 triangle. This is R, just like we call X, Y, and R all year long. They call that R, okay? And y'all see how I can find the angle using trigonometry. And so we're going to learn how to go from A plus BI form, which is rectangular form, into writing it with trigonometry, which is actually in polar form. If I want to get, and I'll end it with here and tell you what to do. If I want to get right here, and I'm in an airplane, or I'm on a boat, I'm on a cruise, and I want to go over to this island. It'd be really silly of the captain to go this way and then do a sharp 90-degree turn somehow in the ocean and go this way. Wouldn't I rather them just turn and go? Okay? So we're going to have thetas and r's, which actually is introducing something you'll need, those of you that take BC. You'll find an angle, how far to turn, and r, how far to go. All right, so part of your homework is going to be to watch a video of me explaining the rest of it, okay? And then a few homework problems. And I may give you a quiz on law of cosine. The homework will be out of the textbook. The good news is it's really easy, but I don't know if it'd be easy to pick up on your own, so I'll explain it. And so watch the video I send before your homework. Girls, keep packing up and leaving, because I need to leave too. The video will be separate from the class notes. I'll email it and post it, okay?
Thank you.
Bye, girls.